Hi, my name is Ong Wingman, and I am the representative for SmartDiag-CXR team. This is my group members, my lecturer Dr. Iwan and my groupmate Chong Ying Hai. We are all from UCSI University. Today, I'm going to talk about how our projects detect lung abnormality such as COVID and pneumonia, and how it can benefit the society. COVID-19 is caused by the SARS virus, and it is an airborne disease that is highly contagious. It spreads between people, mainly when an infected person is in close contact. The virus can spread from an infected person's mouth or nose in the small liquid particles when they cough, sneeze, and speak. According to Google statistics, an estimated 55.6 million has been infected. This has caused an uproar and chaos among the society. 55.6 million is a huge amount of people. How many doctors and nurses does it need to handle this kind of pandemic outbreak? The insufficient number of healthcare workers and the huge amount of workload during the pandemic has caused severe effects on the healthcare workers. According to a research paper written by Delda Mora Abdullah and Dilda Haji Musa, healthcare workers are at a high risk of developing sleep disorder during an outbreak. Their results shows that during the COVID-19 outbreaks, working with the COVID-19 patient has a negative effect on the sleep of healthcare workers. I believe that picture speaks a thousand words. Here is some images of healthcare workers taking a break during the COVID-19 outbreak. Our objective is to 1. To diagnose lung abnormalities in the chest X-ray images such as pneumonia and COVID-19 using the deep learning approach. 2. To create a user-friendly interface so that anyone can use it. 3. To assist healthcare workers in pandemic using a triage method. Triage is the process of determining the priority of patients' treatment by the severity of their condition or likelihood of recovery with and without treatment. The most severe patient will be given a red card, while the least severe will be given a green card. This can allow healthcare workers to effectively treat patients that need to be prioritized first. Our project takes a similar approach to triage. It will sort out patients that has a higher chance of lung abnormalities so that they will check them first. The methods that we will be using for diagnosing lung abnormalities is called transfer learning. It uses the feature extraction layers from a pre-trained model and combined with a new classification layers. Pre-trained models are models that have been trained to perform specific tasks and is open source for others to use. The benefits of transfer learning was that it requires less training data and less training time. To increase the accuracy of our model, data augmentation is applied on our training data. Data augmentation changes the features of an image like flipping image horizontally and rotating the image. These steps will help to introduce more new variants of data and help the generalizing process during training. Then, we will use majority voting ensemble to increase the accuracy. For example, when two models think that the patient has pneumonia, but only one model thinks that the patient is normal, we will choose the majority decision, which is pneumonia. Next is our web app. It consists of the client part and also the server part. The client part is a browser that allows users to access and upload the X-ray images, while the server runs the deep learning model and Flask API to communicate with the client. First, server will open a public access file that stores X-ray images. Client can upload the X-ray image to the public access file in the server. Server will run a deep learning model and read the new image stored in the public access file. Then, it will return the output results to the client. The client will obtain the result and each result will be stored in a list. Lastly, client can download the list of results in Excel form. Here is an image of the client side, and here is an image of the server side. It shows a lot of activities done on the client side. Here is a tutorial on how to use our web app. First of all, type in our website name first, makeitmove.com. Then, we need to go to the setting and allow access of our website. After that, we need to key in the public IP address to connect to our server. The public IP address changes every day, so each individual or organization will require to email us for the IP address. This is actually very useful to keep track on who is using our web app. Let's try to upload some X-ray images from our test data and see the results. So first, let's try a COVID-19 patient. Open, get the results, and we will get abnormal. So let's try another one. So maybe a pneumonia patient. So let's see here. Okay, open. We can try to get the results, and it shows abnormal also. So now let's try another one, maybe a normal patient. So let's open a normal patient X-ray image and then try to get the results. And we will get normal. So let's try another one, maybe another normal patient. So let's try it and press the results. We can get a normal one. So as you can see, all the result is shown below. So let's download and see in Excel form. So we can download it and then it will download it as an Excel form. You can see all here is listed the name and also the results. This is a dataset that we have used for training and testing our model. The abnormal class consists of both chest X-ray image of pneumonia and COVID-19 patients. We have successfully trained 6 good accuracy model, which consists of 2 VGG19 model, 1 ResNet50 model, 2 NASNet model, and 1 exception model. All of the model is open source from ImageNet. The confusion matrix is to help analyze the result of the model on a whole dataset. Since the objective was to classify abnormal from the chest X-ray image, the abnormal class is my positive result, while the normal is negative. Accuracy is the evaluation on the total number of correct predictions over the total number of data, but this can be affected by the imbalanced data. F1 score represents an unbiased accuracy since it does not affect by the imbalanced data. This is the confusion matrix and the results calculated from the confusion matrix based on the training dataset. It has an accuracy of 92.9 and F1 score of 95.1. This is the confusion matrix and the results calculated from the confusion matrix based on the testing dataset. It has an accuracy of 94.3 and F1 score of 95.5. The accuracy for both training and testing dataset is slightly different due to imbalanced number of data. But the F1 score for both is very consistent, so normally F1 score will be used as a reference to determine the accuracy of a model. Is there any place for the product to be on the market? The answer is yes. Due to the pandemic and the fact that not everyone can assist doctors without the proper education and license. Doctors are in dire need of helping hand. The helpers will need to have experience in order to assist the doctor. But using our project, any volunteer can assist doctor after learning to use the website. What are the short terms and long term potential? The short term is that it allows any volunteer to assist doctor during the pandemic. But in the future, when more data is gathered, it can assist on other lung-related disease as well. Our project target market will be hospitals, St. John, Red Cross, Red Crescent, or any volunteers organization that wishes to help the healthcare workers during this pandemic. Currently, we did not find any project that commercialize chest X-ray diagnosis for public user. This should be the first project that allows any volunteers to assist doctors in triage for this pandemic. Can our project benefit the society? Of course, healthcare workers like doctors and nurses spend hours and even days in order to tackle this pandemic. Our project can create an opportunity for public volunteers to assist the health professionals. This can create a larger workforce and lower the working loads of the healthcare workers, relieve stress and prevent negative impact on healthcare workers. It can also help save many lives by acting as a triage. This will help to reduce chaos and create a more systematic way to treat the patients. Our project is an alternative method for antigen test. Antigen test uses a long nasal swab or throat swab to get a fluid sample and test for disease. Our project can reduce the usage of this nasal and throat swab, thus reduce the wastage. In conclusion, our project has a test accuracy of 95.5%. It is reliable and user-friendly for everyone so that any volunteers or organization can access and use the technology for the benefits of society. Thank you for listening to our presentations, and I hope that everyone stays safe as well.